Romanian. How do you feel? It's okay for you if we're going to have it in Romania? How do you prefer? It's actually very informal and English. Tu vorbești română, de ce ai zis English? No, okay. Cool, then we're going to switch it to English. So today's topic, cloud cost, Kubernetes, and where your money floats away. This is a rather generic title, but before we start, I would like to set a little bit the expectation, more exactly your expectations with regards to today's meetup. If someone expects that by the end of this session, you're going to have a, let's say, clear definition on how you're going to cut your cost or how you're going to do your cost reduction, then be prepared to be disappointed. Because this is a rather complex topic, and it's very intimate. In what sense? Because applications, no two applications are the same, right? So having a clear definition for cost reduction, it's really, really difficult. Now, first and foremost, today in here we are two, let's say, groups. First one is the Cloud Native Bucharest meetup, and the second one is AWS User Group meetup. So I would say we are the best here in the room, the best IT in Bucharest. And today we're going to have three presentations, two, I don't know how to say, two concrete ones, mainly one addressing GCP costs, creative cost optimizations. The third one, operations taming, the AWS cost monster. And the first one, which is my presentation, which is going to be more of a rant, a personal rant, and a highly opinionated talk. The second talk is going to be presented by Bogdan and Mihai, our hosts tonight here at Adormi, and the third one by exactly this guy who is entering, meaning Bogdan. Bine venit, Bogdan. Just in time, exactly. So he will present our third presentation. And my purpose today is just to create the setup for the next presentation. In what sense? Because we have a mix of people in here. How many of you would say that are, I don't know, highly skilled in Kubernetes? Please raise your hand. Okay, no, that's good.
How many of you have imposter syndrome?
Yeah, that's a healthy one. And how many of you have, I don't know, a very proficient experience in cloud? Okay, the same people. Wow. So the idea is that when you're doing a presentation, it's really difficult to address all the, let's say, use cases and levels of knowledge, right? So I'll try to construct something from the beginning, and then I will let Bogdan to carry on with concrete cases. Now, a couple of words about me. I would say from this slide, one thing is important. First and foremost, that's my handle. My name is Alex, Dejanu Alex. I'm one of the AWS user group leaders. So if you have any questions, curiosities, or I don't know, proposals for various topics presentation, feel free to reach me on LinkedIn, Twitter, whatever you like, and I will gladly answer you. Now, our entry point in today's presentation, what is currency? So currency, generically speaking, is a mean of exchanging and a thing that facilitates our transactions, right? Concretely speaking, we are talking about money in our day-to-day work. And I don't know if you are familiar with this aphorism, time is money and customers are gold. What I can tell you for sure that almost everyone from this room is working under this aphorism. In what sense? Even if it's a big organization, a big multinational corporation, or like even a small startup, this is like the thing that puts pressure on us with a small, let's say, difference between the layers. And why I mean by that, I'm talking about currency management. Now, if here is very interesting, the duality of this currency management. In what sense? If you are, let's say, a C-level or a board member, the currency for you, it's exactly money. That's the most often thing that you're going to play around. But if you are, I don't know how to say it in English, but if you are like, you are a simple worker, the currency, unfortunately for you, is not money for you. It's actually the time that you invest there. Why I'm saying this? Because you're not going to receive next month 2x your salary or something like that. And for example, I was involved in what I call clown-to-clown conversation. And here I will going to switch a little bit in Romania. when you are starting to say, bă, dacă plec de aici, ăștia mor, nu fac nimic fără mine, that's going to be a clown-to-clown conversation. And unfortunately, it's a generic thing, but as I said, the currency for most of us is the time that we invest in a certain technology, organization, or whatever you want to call it. Now, also talking about cloud, right? If we just look a little bit besides the technical aspect, like virtualization, data center, things like that, the cloud need has a very enforced root in business case, right? If you guys remember the ones that have been to the AWS Frugality Fest, we had to lower the total cost of ownership. That's the entire idea, like capital expenses and operational expenses. You have to reduce the amount of money that you invest when you buy something, like a solution, a server, or a data center, and the operational expenses. So that's the underlying idea of the cloud, as I said, besides the technology aspect. Now, and we all witnessed this great tidal wave of shifting from on-prem to a cloud provider, a public cloud provider. But also we've seen lately the shift from one cloud provider to other cloud provider. And here are two things. Like the relationship with your cloud is like a relationship with your wife, or I don't know, with your girlfriend. You have to be committed. If you think about it, if you are like, you all know the pricing plans. If you are on demand, you're not very invested because you can get away almost at any time, right? So it doesn't make any sense to talk about cloud optimization if you are working on demand. On the other side, if you are working on reserved instances or even more savings plan. Have you heard about savings plan? That's a good indicator that a certain enterprise it's very involved in a cloud relationship, so to say, right? And this is very important. Of course, the other aspect is when you want to change your girlfriend and you're going to go from one cloud provider to the other, then you have to think about egress data, how much you have to pay with regards to changing that. And now a very interesting thing, if you are strictly talking about compute, because at the end of the day, we need three things. We need network, we need storage, and we need compute. If we are talking about compute, doesn't matter the, let's say, the flavor of the instance, being a general purpose, a compute optimized, memory optimized. If you see here in the second column, we are talking about vCPU, virtual CPU. And that's an interesting thing because we are actually talking about a time-based entity. So we actually rent time. So the first thing that you can optimize, from my perspective, is just shut things off. And this is a very important thing. It's with an asterisk. You do this when you have predictable workloads. So to say, concrete examples, if you know your customers don't use the solution during the weekend, it's okay to scale down. If you know the developers don't use that certain dev environment after business hours, just shut it down and then start it up back in the morning. I've done a couple of things like this. These are low-hanging fruits, easy to do. But first things first, it's healthy to shut things off. Now, next thing, addressing another important subject, microservices and distributed system. So if you think about Kubernetes is on the market for 10 years, I would say, from 2014, right? So 9 out of 10 jobs will have a Kubernetes flavor into it, right? And I'm just curious, is someone in the room which is not using Kubernetes? Cool, 1, 2, 3, 4. Okay, that's good. It's a healthy thing. From my perspective, it's not mandatory to use Kubernetes. This is like my own top-down approach when to use Kubernetes and when not to use it. So here, if you take it from the top level, if your app is containerized, first and foremost, if your app is not containerized, then either you work in an embedded software environment, either you should change your job. Then, if your app is containerized, if it's complex, you have multiple containers, if the answer is no, just go for a simple thing like Docker Swarm, Docker Compose, or any cloud provider has a container service that can serve you. Now, the next thing, your application, it's highly complex. You want to have automated deployment and scaling. If you don't want to have this, you're going to have lots of colleagues, lots of friends, because lots of people will be involved doing the manual stuff. And then the next layer, this is actually the secret sauce of Kubernetes, I would say. If you really want resource utilization, multi-cloud deployments, and a thing which is called automatic beam packaging, meaning the scheduling part of Kubernetes, that's the real thing. If you want to have that, just go for Kubernetes. Otherwise, be prepared to spend a lot of money. Now, in Kubernetes, I would say our entry point, a very, very simple thing. What's that, Mark, for Windows? It's a question?
You say that Linux don't run well.
Okay. So here, I will take a high-level approach, a very, very simple thing. So from Kubernetes perspective, we have a couple of things. First and foremost, from my perspective, the magic component in Kubernetes is the magic component in Kubernetes is the scheduler. That's the part of the control plane that does the heavy lifting, so to say. And Kubernetes has two concepts with regards to resources: request and limits. And it's very simple. Request is the minimum amount of resources that it's needed for your application, and the limits are the maximum amount of resources. And you have to place this for each container in your pod, right? And as I said, we have two main resources: CPU, which is measured in millicores, 1,000 millicores equals 1 core, and we have memory in megabytes. And I will try to do a small demo for you, something hands-on. But let's take it step by step. I don't know, do you have any questions until now? Okay, cool. As I promised, let me show you the kube scheduler. So this is a simple kube system, sorry.
We have this allegation from the chat that containers don't run very well on Mac or Windows.
So we said scheduler, right? So here, just for you, can you see all the way back? Vedeți sau nu? Wow. Păi măresc fontul, dar chestia e că a rămas blocat. Deci. Mamă, dar nici măcar nu erau containerele astea. Din nou am ajuns acolo. Să intru să dau share din nou? Păi ceva? Eu acum am făcut o grămadă. S-au întâmplat multe. Okay. Let's see if we can see something here interesting. But dacă schimb așa, wow. Okay. Okay. Let's see. Perfect. Să scot terminalul din full screen? Ok. Nice. Gata. Pe continuă tu, cine a zis? Okay, so coming back. So the scheduler, currently I'm using a simple setup. Let me show you. I'm using the cluster provided by Docker Desktop. It's one node, which is the control plane, and the worker nodes for me. And here we can see the scheduler is actually running as a pod in the control plane. And this one does all the fancy thing. I'm a big advocate of using the CLI for documentation. So I told you about limits and requests, but you don't have to believe me. You can do kubectl explain almost any resource. If we do explain pods, specs, because I'm pretty sure that's a spec, containers, and I'm pretty sure you're not seeing anything. Huh? And let me go directly to resources. So here, as you can see, so as I said, use kubectl to get the documentation. We have the limits, which it's clearly described in here, the maximum amount of compute resources allowed, and requests describe the minimum amount of compute resources required. An interesting thing, if a request is emitted for a container, it defaults to limits, right? Now let's see. Now let's see something, a concrete example. So I have a small application, which hopefully works. It's a simple web server Let me start to see if it works. S-a blocat?
No.
Okay, it's running. It's running on which port? 3000. Okay, so it is running. So it's a very simple app. Doesn't matter. Now let's take it to Kubernetes and up app autocomplete. Deploy, yes. Yeah. Now let's deploy it in our small cluster. Up. But you know what? Let's do something interesting. Let's dry run client and let's serialize it into a YAML. Up. Doesn't matter here. And if we take a look at it, so this is our application. It's, as I said, our Docker image. So this will work, but we talk about requests and limits, and we don't have it here. Do you think it's a problem for us or not? Yes and no. That's a good question. So first and foremost, we can see that if I want to deploy this application, how do I call it? Up, kubectl, up. It's in the default namespace. We have it here. We can even test it up. And we can make a small service for it just to see it in our browser. Up. And it's no longer on port 3000. It's in 333. Yeah, so we have the application which is running. So we can see that the application is running, but we didn't set any requests and limits. And we've seen that for Kubernetes, there's no problem. But if we do something else, I have in here, let me show you. Oh, I have a folder which contains a couple of deployments with various containers. Basically, they are Nginx images, but I will deploy all of them. And let's see something interesting. So I want to deploy everything in here. And it's in the which namespace? Demo namespace.
Is this running on your laptop or AWS?
In my laptop. Everything is recorded.
Everything works.
Yes. So here we have 4 different pods which are running in our demo namespace. And as I said, we have requests and limits. And one thing which I highly recommend, I'm going to show you also this later, is to use the Kubernetes API imperatively. So for example, I just wrote a small script, which is actually packaged as a kubectl plugin. And if we take a look in the demo namespace, we can see, we can see that we have our pods, demo 2, 3, 4. And here we have the quality of service for these pods, guaranteed, burstable, best effort, burstable. Do you have any idea? Have you heard about them? This is, some of you have heard about them. These are, let's say, the entry point when talking about resource management in Kubernetes. And so we have requests and limits that we place on containers. But then from Kubernetes perspective, Kubernetes will place a quality of service for each pod based on what we said that we need in terms of requests and limits. And here we have the definition. So let's start with best effort. If the containers in the pod do not have any requests and limits with regard to memory CPU, then it's a best effort. And the kubelet will prefer to evict these kinds of pods. Then next layer is burstable. At least one container has a memory or CPU request or limit, and guaranteed every container in the pod must have a limit and a request, right? So why is this important? I've seen projects in which, let's say, the de facto approach was not to put requests and limits. Even more, there's a trend with not setting limits on your pod because CPU is considered to be an elastic resource. And also, just to be more clear, if we take a look at pod resource inspector in demo, Resource inspector. Here we can see also what does just that. We can see once more our pods, and let's take, for example, one of them, demo 3, and see exactly how it looks. Din păcate se vede jos în acest fac. We can see here that we have one container in our pod, which is an Nginx, and it doesn't have limits and requests. And this one, if you remember, is the burstable one, right? Sorry?
Isn't this one the
Best effort. Sorry. Yes, thank you. Also, we can take a look, for example, let's see, demo 2, what does it have? You see, this one has limits for memory and requests for memory, but it doesn't have anything with regards to CPU. Do you know which class is this one? Burstable, yes. Cool. And now this is the entry point in resource, let's say, management in Kubernetes. Now there are lots of different things that you can, how can I say, customize and do in Kubernetes. And for that particular thing, we have lots of toolings. I can show you another thing. Let's see. I think this one. So, of course, one of the things is not setting your requests and limits, but the other thing is not set them properly. In order to set them properly, at least my personal view on it is just you're going to set request equals with the limits, and the mandatory thing is to run load test. If you don't run load test, it's difficult values for sure. And then, of course, you have different layers. And these are things which are generically called misconfiguration. And here I'm using an old tool which is called QBuy. For those who don't know, QBuy, it's actually based on open policy agent. Basically, it verifies a couple of rules with regards to your cluster. And I will run it for our cluster in here. And it will create a small audit, so to say. So it's based on some Rego rules. And here, unfortunately, I don't know how to make it more visible. If I
can you reduce it to 2/3? Up or 2/3?
Să-l fac mai mic ăsta?
Da. Să mai mic, cam cu o treime.
Mai spart o treime. Care a vorbit?
Ai putea să arunci și output într-un fișier text și după aceea să faci zoom out de fișier?
Reduci partea de jos.
Așa vrei? Hai să vedem. Ok. Let's hope that we can see. Am înțeles. Da, gata, smart. Da, se vede mai bine. So here we have different levels with regards to let's say our problems. And what I wanted to show you in here is that besides not having limits, requests, and things like that, we also have not run as root. So things with regards to processes which are running inside your container. Probes, things with regard to your readiness, liveness, health check probes. So the discussion is very broad with regards to Kubernetes. The part with regards to CPU limits, memory limits, and requests is just the entry point. Now, I can show you one other thing. Sometimes you might have problems. Let's see in the demo namespace. If you misplace your values, have you seen things stuck in pending? So what happens if we do a kubectl describe this pod, which is this one? Let me specify the namespace. Here we can see that 0 out of 1 nodes are available, insufficient nodes available. Now, personally, I've seen this, and this was a result of bad capacity management, so to say, and also a result of not running load tests, because at a certain point in time, it might work with your values that you have, but the nature of the workloads is highly dynamical. Now, coming back to our slides, I have some concrete examples with what happens when you misconfigure things or you miss things. And it might look like this. So this is an actual print screen from an environment. And you have an alert and you see things like this. And it's very difficult to debug and to see where are the problems. And I would say the easiest thing to spot is the out of memory killed, 137, I think. And this is because memory has a particular thing is not the elastic resource. So if you mess around with CPU and you, let's say you're not very accurate with your CPU, you're going to see a performance issue and some throttling, right? Because coming back with a time-based entity being the virtual CPU, there's not such a big problem. But with memory, if you mess around, your pods are going to be killed. Now, the nice thing is that in this day and age, we have lots of toolings. So we have, personally, I've used a couple of them. So it's crazy. We have Goldilocks, we have Carpenter, Kida, QBuy, KubeCost. I don't know. Have you heard about them? Have you used them? So basically, just to give you like a small idea what are these tools about. So first thing first, they address mainly these misconfiguration problems and then the cost optimization things. And in Kubernetes, we have another important thing, which is called an event. So for example, I can show you later on. For example, KIDA, which is something with, I forgot the acronym, but it's based on events, right? Events which are taking place in our cluster. When we did the describe, we actually seen an event there, right? And then you have QBuy, the one that I've used, that shows you this configuration with regards to open policy agent, KubeCost. Then you have Carpenter, Goldilocks. Oh, here an important things like when addressing cost issues, you're going to hear things about scalars. Autoscaler, vertical, pod autoscaler, horizontal. You have different ways to scale your workloads in Kubernetes, but you have to pay attention, as I said, on your load test. That's the most important part. Now, what are today's takeaways? So first and foremost, compute equals cost. So whenever, I'm pretty sure that many of us are working in a over-provision environment, because at the end of the day, if you don't feel the pressure of, I don't know, performance issues or coming back to our time is money, if no one presses you, most likely you're on a over-provision environment. Otherwise, if you're under-provisioned, you're going to see some pressure from the management side. Now, the right sizing of your workloads is tricky. As I said, run your load test, start with that. And from my perspective, you cannot have both, meaning a good cost and a performant application. It's a trade-off. You have to find your sweet spot, but you cannot have both of them. And one thing which I've seen very often is that people think that Kubernetes having the scheduling part, the high availability part, the autoscaler will do magic for them. But unfortunately, if the infrastructure is, let's say, misconfigured, it's under provision or is not, let's say, you don't have a good capacity management, Kubernetes will not do magic for you, right? And basically, I would say the takeaways, don't forget to turn things off. Also, if you want to be invested in a cloud, be sure that you're going to a savings plan. And another low-hanging fruit, just upgrade your instances. Like the first thing that you can improve in your cloud environment, you just go for, I don't know, Graviton instance. So upgrade them because that's the optimal way to go in a cloud environment. Yes, and I would say I will not keep you any longer. As I said, if you have any questions, this is my handle. Otherwise, thank you very much. Salut, să fiu beri. Cool. Now, Bogdan and Mihai will present you the GCP scenario. I don't know. How do you? We can also. Someone asked if I tried zero scaling. I'm not sure what that means. Can you be more specific? the infrastructure to scale down to zero near. Yes. I've tried that with our dev environment, meaning that during the day, the developers are working on feature and things like that. And it was in a cloud-based solution. And after business hours, we just made a small controller, actually an operator, that scale things down and start them up when they are in the morning.
Vorbim noi despre asta detaliat.
Okay. Yeah.
Short question. Do you know how did you come to the conclusion to use Kubernetes instead of Docker Compose? When was the break-off point? And you said, okay, it's complex enough.
That's a good question. To be honest, I was involved in both types of project, one of which is still uses Docker Swarm. I think when the application is complex enough and you're going to have to manage things like state within your application, and you want to have multiple cloud support and multi-region support and things like that, you're going to go to Kubernetes. And also, if you think about it, so when you start with container, right, you're going to build your container images, and the first thing, from my perspective, you should start with Docker Compose to see exactly how containers talk to each other, right? And then the next natural step is, okay, I would like for my containers to talk with other containers from other machines. And you start to play with networks and container overlays and things like that. And you're going to see that in Docker Swarm, it's difficult to manage this inter-container communication, right? And when you start to spread containers around different machines in a cloud, maybe, you're going to maintain the, let's say, the network stack, the service discovery, and the natural step is going to Kubernetes, because Kubernetes has some vanilla objects that can help you, things like services, ingresses. But yeah, as I said, I would say it's a gradual thing.
So first would be going multi-cloud.
Yeah, going multi-cloud, and yeah, just scaling your application. Roger. Yes, please.
You have not mentioned anything related to the number of namespaces or number of nodes that can be deployed on a node. Are those going to affect the performances of the respective node? If I have a higher number of namespaces or a higher number of pods, will it be harder to scale this?
So that's a good question. So let me repeat it to be sure that I understand. So when we increase the number of namespaces, if we're going to see some performance issues.
Yeah, and the same question for the number of pods. I know that there's a hard limit for pods, like over 100, that you cannot deploy more than that. You have to change something in the core to allow a higher number of pods on a single node. So there are some limits also to the number of items that you can have in your Kubernetes.
Yes. So I think the number of pods, it's strictly tied with your maybe offering, right? If it's a managed service, it's a EKS or AKS, I think it's very different from cloud to cloud. And coming back to the namespaces, that's a good question, because of course you cannot create namespaces like to infinite. And here you can find different other objects in Kubernetes. I didn't mention them, but that's the next step, having resource quotas, right? So if you are a Kubernetes administrator, you can enforce rules with regards to, okay, you can schedule this number of pods, or you can schedule this amount, you can use this amount of resources for this namespace. So we have various control mechanisms in Kubernetes to control the number of pods, number of namespaces. Also, you have pod disruption budget. You have taints and affinities. So this was like the tip of the iceberg. But as I said, we can talk about it afterwards. But Kubernetes offers you different mechanisms to control how the resources are created in your cluster. Okay. Mai aveți o întrebare? Tu, scuze.
My question would be, you mentioned about load testing.
Yes.
Do you have any tooling that you
No, actually, I only use JMeter once within a project. But Lucrăm la aceeași firmă. But what I am trying to say, so the project has some problems, either they are coming with a request, we need to cut costs, or okay, we need more resources, we need to scale up the infrastructure, add more resources. Then you have to push back and say, okay, we need to run some load tests. That at the end of the day, honestly, doesn't matter with what framework, but to have some concrete results with regards, okay, this is, you have to find your baseline. This is the peak, and also you have to know if your workload are predictable. As I said, okay, I know that in a certain period of time, I will have a high number of users, or this is the maximum threshold that my application can sustain. And then you're going back to your YAMLs, update them, and then of course you're going to have some additional cost and start using. In cloud environments, I highly recommend those calculators. Every cloud provider has like instance calculator, and you specify the amount of CPU, memory, the flavor of your instance, then you're going to have a roughly cost. Welcome.
So function with different types of instances to always have limits on our.
With regards to instances, I would say first things first. If you can stop them, stop them. Whenever you can, just turn them off. And also, it's very healthy to upgrade them. I mean, to go. When I say upgrade them, not in terms of upscaling, not adding. I know they were pods. Okay. So.
Yeah, if you can make like the analogy with ECS, because I don't use Kubernetes, there's such a thing or set of ECS.
Okay, so it's in the sense of quality of service, Kubernetes looks if you have limits and requests for your containers, right? If you have them for all the containers in your pod, if you have, okay, I will use this amount of CPU, this amount of memory, and you offer this information to Kubernetes, you're going to have the guarantee quality of service. And this offers you a protection for your pod to not be evicted. Because if I will schedule a pod, as we've seen, without any requests and limits, I'll just do it freestyle. Because it's not mandatory for me to specify the resource which my application will consume. What Kubernetes will do, if the amount of resources will increase, so the user will start to use our application, my pod, which doesn't have requests and limits, will be evicted. And we're going to see, like, I've showed you the terminating state for your pod. So
okay, so in ECS, if you run on private, this does not happen because underneath serverless. So
yeah, serverless is another discussion. Serverless is, that's a different beast. Yeah, but yeah, that's true. And the analogy stands.
So that's why you have ECS.
Exactly. Welcome. Bun. În continuare, urmează Bogdan cu Mihai. Corect. Îl opresc sau tot?
Okay, that's full screen, so am mai editat ceva. Ce trebuie să-i fac aici? Companion. Să nu facem microfon. All right. Well, before we start the presentation, I just wanted to take a 30 seconds break to tell you about the Cloud Native Bucharest community for the few of you that are either new members of the community or just members of the AWS community. So we started this group maybe 5 years ago. We had almost monthly meetups. And the semantic scope we're covering is like 3 different things. First of all, we're kind of a Kubernetes user group, or more largely a CNCF user group, because all the other projects are under the CNCF umbrella, like Prometheus and whatnot, are in our area of interest. Secondly, we are interested about use cases in all public clouds. So we're kind of vendor agnostic in our interests. Things like serverless in various clouds, or whatever managed services exist outside the scope of the open source CNCF landscape. And thirdly, we care about building and operating cloud native apps. So that means microservices, architecture, and all the practices and the pains associated with this. So that's kind of what we care about as a group. And welcome. Now, hearing Alex's very generic presentation and thinking about our creative use cases, I realize we're not that creative. They're actually good practices that many of you probably share. So I hope our particular use cases are a good hook for a good conversation. So please go ahead and ask what didn't work, how did we do that, or this, and so on. Before we start, I just want to give a bit of context. How come we care about this stuff? Because we are a panty and bra and corset and other lingerie items brand. So we are this direct consumer brand. That means we design the stuff, we manufacture it, and we sell it on our website and in our apps. And we're a technology company in the sense that we have more engineers in our team than all the other teams combined: marketing, finance, fashion design, supply chain. So as a, let's say, vanity metric, we have almost 500 GitHub repositories, 25 development teams defined in GitHub, 90 people that need to commit code. And we were recently acquired by Victoria's Secret for $500 million. And they say they bought 2 companies in one profitable growing brand and the technology company. So we take that compliment. Cool. And well, how did we get here? We had like a super shitty Magento instance running on a VM somewhere in anonymous collocation data center. And then we kind of scaled the infrastructure as we grew the business. We ended up having 30 physical servers, a few racks dedicated for us in a cage in a Virginia data center. And besides Magento, we started to build our own tools, various monoliths in Laravel or whatnot. And then as we grew the team size and we start to have a more, shape of an organization with teams and roles and so on, not just some random guys writing code, we ended up switching to microservices, mostly for team ownership reasons. At that point, we had 50, 60 servers in the data center. We started to have a pretty solid data stack in Google Cloud, BigQuery and data science, machine learning, all that kind of stuff. And we started to use Docker Compose and Swarm and play with Kubernetes. In 2020, we moved to Google Cloud. By that point, we had migrated all our workload to Kubernetes. And right now we just have microservices, our homegrown tools, GKE, the data stack from Google Cloud, and we use Kubernetes for all our workload, our production workload. We use serverless for data, so cloud functions and cloud run and stuff like that. And we use VMs for stateful workloads like MySQL or Redis and so on. That's where we are. One note, somebody asked, when do you switch from Docker Compose and Swarm to Kubernetes? We were actually quite happy with the overall experience of that stack. I think we started using it the same year when it was included in Docker Core. When they include Docker Swarm, I think it was in April 2017 or something. And it all went fine, except under high load conditions, the network layer would randomly and impossibly to diagnose croak on us. So it was pretty reliable when thinking about network traffic. So that was the main reason why we started to research alternatives and started to use Kubernetes. And when we evaluated initially, we looked at Docker Swarm, Kubernetes, and what was it? From HashiCorp?
Nomad.
Yeah, Nomad. We were looking at Nomad as well. And we thought Kubernetes was a huge overkill, over-engineered thing for us, but things happened. Cool. And today we'll just, oh, that's horrible contrast. Well, I can read it. 5 ideas we're sharing: bin counting, provisioning sweet spot, performance testing and APM, preemptible instances and janitor. And before we, let me do something. There we go. Before we go to those, I just wanted to give a bit of context of where we were just before moving to Google Cloud. If you look at the diagram on the right, the yellow stuff was Kubernetes, and the blue and red stuff were our legacy workloads that were not containerized yet. In terms of cost, so we just look at the numbers of servers and their associated cost. And if we zoomed in into Magento, we did a bit of APM breakdown using New Relic and figure out which features are consuming which amount of workload, which went directly to infrastructure costs. And what we realized is, if we were to lift and shift our infrastructure, we'll probably triple our costs, or even worse. So we realized, okay, the cloud offering is indeed magical with their elasticity and absorbing spikes and so on, which was indeed useful for us being the seasonal business and the US-only business. But even in that case, it was expensive as hell. So before we moved to Google Cloud in 2020, we spent some intense 6 months to re-architect the bits and pieces that were really, really painful. So we look at the big resource suckers and we put them on a weight diet. We killed the most heavy endpoints and migrated to microservices that were running in Kubernetes. And at the end, we containerized the now slim legacy apps, and we just added them to the Kubernetes cluster like their pre-existing siblings. And we also killed and decommissioned any legacy infrastructure element that was not easily supported in the cloud. For example, we were using Gluster FS, for shared file system. So we moved all the application code to use Minio. And then after we switched all our file storage in Minio, we were able to easily switch to Google Cloud Storage and so on. So we had to do all this kind of modernizing and re-architecting so we can take advantage of the cost reduction promised by Google Cloud. Cool. And then I leave it to you.
Okay. Okay, so I am Mihai Gogu, and I am a YAML engineer at Adormi. And I'm going to tell you about what we tried to do and what we did to scale down the costs, especially for the Kubernetes clusters. So as Alex said earlier, if you don't use it, you should shut it down. So this is what we are doing with our dev environments. So we have, each team has 3 dev environments, meaning 3 namespaces in a cluster. And on average, there are around 20 namespaces that are with an average of 50 pods each day. So this would amount to some costs. So we developed this janitor because it comes at the night, cleans up, and shuts down the lights. And what this is a Kubernetes operator, which comes with a custom resource where you can define a schedule when you want your namespace to be shut down. So each team defines like from 8 o'clock in the evening until the 9 in the morning. They can pause it or suspend it on demand if they need to do this. And I can also show you the interface. So how the custom resource looks like. It's just a simple custom resource. You can enable or suspend your namespace. Zoom. Okay. Better. Yeah, you can define your interval when you need your namespace to be shut down and when you need it to be start up. And you also have the option to suspend it on the weekends. So we needed this flexibility because different teams need to expose their namespaces in the outside, people in US, and they are on a different schedule. Maybe they will check things in the weekend. So we needed a flexible way for them to manage their dev environments. Yeah, and some things that were not yet implemented. Maybe never. Yeah, and you also have the option to suspend your namespace on demand and resume it on demand. Maybe, I don't know, you came early to work and you need to start it and start your day. Yeah, and started as a hackathon idea.
Yeah, and if you probably can see the font, it's probably a 10K a month cost for our development cluster. So this is the problem that we are mitigating with this tool.
Yeah. Okay. The next thing.
Wait, we have a question.
Okay.
I would assume that the unit of scaling is the namespace, right? So you're scaling up and down with number of namespaces. Why is that the case? And not the development of service or whatever? Why did you choose a namespace? Is it easier or?
So what it does, it doesn't touch the namespace entity per se. It only scales down the deployments in a certain namespace. So yeah, because
so you don't actually delete or add more
no.
You just scale the deployment.
Yeah, we scale the deployments. We want all the configurations to be there, and people shouldn't need to redo their environment. Just put it to sleep.
And the stateful stuff is super small and cheap. We have one shared Cloud SQL instance for all the development databases. So.
Yeah.
partitioned, or what are the?
No, it's tiny. You just have the test data, so you don't really care about.
Yeah, and for other services like Redis with persistence, we have some volumes and some in the cluster, so the data will be there after the pod restarts. Okay, so another thing that we did to scale down the costs was to use preemptible instances. So if you're not familiar, preemptible instances are not guaranteed, and they can restart at any moment, and they are prone to multiple restarts, and you might not be able to provision preemptible VMs at certain points, like in the period of Black Friday, for example. We dropped the preemptibles because they are simply too unreliable, and we provision normal VMs, but after that period of 1 week, 2 weeks, we switch back to preemptibles.
And for the infidels in the room, they're called spot instances in AWS.
Yeah. Yeah, so you can have a discount of 60-90%. We use them for the dev clusters, but also for the production cluster. We have a lot of web servers in production that run on preemptible nodes, since we have multiple instances of the same app, and they are distributed across multiple nodes. The chance that all your app will be down at some point is pretty low, and Kubernetes will just spin up the rest of the nodes, the pods that are missing. And the Kubernetes improved. At first, we had to build our own tiny app to manage the preemptible restarts, because Kubernetes wouldn't know how to interpret a preempt. But now Kubernetes does this, and it's better than at the beginning.
And one note here, when we look at the type of workloads, so considering we have mostly stateless API traffic, it's really safe to use preemptible. There is really no long-running process that is impacted by this. If we had any long-running process, we always use regular instances. And regarding the provisioning of the node pools for this API traffic, we have a pretty small baseline of regular nodes just to keep the lights on that are at full cost. So we absorb most of the traffic spikes through preemptible instances. And for these VMs that are kind of predictably running on regular instances, we try to use as much as possible committed use discounts for a year, 2 years, 3 years, depending on the, our capacity predictions that we.
Yeah. And if we manage to have a super slim app, we have enough space to mine Bitcoin, or we have the VMs, they're committed. Yeah, and you can also, maybe we're gonna try and do this. You can also move your workers on preemptibles, but you need to invest some development work there so that your workers can act on termination signals and gracefully shut down. We don't have that yet, but maybe we'll have that also.
This is based on some kind of infrastructure as code. I would assume, because having spot instances means that you have to actually control this infrastructure.
No, in the GKE cluster, you can have multiple node pools of multiple types. So
just pure GKE.
Yeah.
Yeah.
All right. Performance testing. So this one is kind of an old tradition, because when we were using regular data center, we had fixed capacity. So when we had our seasonal peaks like Black Friday and Valentine's Days, we had to be very careful to have the right capacity, and we were also very poor. So we had to be cheap about it. So what we did, starting September-ish, we started to run heavy performance testing. to answer the question of marketing, how much traffic can we hold? And we started to do Gatling test covering the realistic uses scenarios. So we are looking at our regular access logs during the spikes of traffic, and we try to replicate the same ratios of endpoint frequencies in our tests. And at that time, it was kind of existential to do good performance testing because otherwise we wouldn't have enough servers to cover the spikes. And what happened is during these tests, we had tons of feedback for our engineering teams about your app is slow as shit. What did you do? Last year it was faster. And we used a lot of APM to figure out how might we optimize the code. So it's a really ongoing continuous improvement. Every cycle you have this stress testing, then you have APM profiling the code, the SQL queries, etc. Optimizing, and then restart. And this is an example. We did some simulation, and you see the average load time decreased because some people removed some heavy code that they had. And now, since we moved to the cloud, what happened? We made this whole process automated and self-service, so teams can contribute to the scenarios. They can run it on demand. We had it scheduled on a monthly run, weekly run, depending on the period of the year. And the reports are going to the teams, and they can react on them. And if they don't react, they are reminded to react. Wonder if there's any question here.
APM? Which kind of APM?
Yeah, New Relic, mostly. Yeah, but this is really important because, as Alex said, every second of response time is equally correlated with the cache we play to Google. So performance optimization drives the cost down. Yeah.
So as we were migrating your services to containers, so did you see throughout the cycles changing the nature of traffic? And were you seeing bottlenecks moving from one side to the other, and basically the environment not going extinct that fire?
So the question is, if after moving to Google Cloud, did you see a change in the load patterns, right? I think our app was modernized sufficiently that the comparison was not very useful. We had shittier code before the migration. But I don't know, we had an on-prem Kubernetes cluster for a couple of years, and we had GKE after, and I wonder, Mihai, in the operating that cluster, did you have any huge differences in the workloads?
No. I mean, just
Not really, no. I think the shittiest problem on-prem was the nodes were not very balanced. We knew, oh, it's that node with the bad memory, it's that node with whatever. So we kind of knew the nodes by name and kinks, which was not the case in GKE.
yeah. Okay, so
Sorry, speaking of the migration, you mentioned that the cost after migration will be 3 times more expensive, right? Before you optimize your applications.
Yeah.
How are you able to estimate?
By looking at the size of the slices in that pie chart in a couple of seconds. So it was not a very scientific estimation. But considering on-prem with non-virtualized hardware, you have that breakdown. We could only assume the breakdown is worse in Google Cloud with all the layers. So by killing completely that slow workloads, we simply had fewer resources needed regardless of the vendor. even on-prem or in the cloud. So yeah, we just reduced our usage a lot, so the cost should have decreased by that ratio.
Okay, and the next thing that, it's nothing too complicated. So you should, we think you should set the resources right for your applications, the requests and the limits. So you need to find the sweet spot. If you go too low, then your app will be throttled, and you risk that multiple instances of the app will be scheduled on the same node. And when the traffic comes and they need more memory or more CPU, they don't have enough because you over provisioned a node. So let's say you have a node with 1 gigabyte of RAM. You say, okay, my app runs with 100 megabytes. Kubernetes will schedule 10 of your apps on that node, but when in traffic, your app will actually consume, I don't know, 150 or 200 megabytes, and Kubernetes will have to evict some pods because you don't have enough resources on that node. So you won't make anything good with setting the request too low, because even if you have the limits, Kubernetes needs to have those resources on that node to allow it to use more than the requests. And another thing for us is we don't have big unplanned spikes. So if you look at the auto scaling, we can run with a pretty low baseline, like 3 replicas, because and for the periods that we expect big spikes, we kind of know them, and we have a small app that we are calling warmer, that we can trigger, and it will provision this certain metric in Prometheus that our HPAs are configured to use, and they will know that, okay, this metric has this value now, and I need to scale to max replicas or something. So if we know we have a campaign, I don't know, a commercial on TV or something like that, we can tell the cluster, okay, scale it up because we are expecting a big spike. And with our pattern of traffic, the scaling that is offered by Kubernetes, and actually it's not Kubernetes that is the bottleneck, it's the provision of new nodes in the cluster that is the main bottleneck. For that, we have over provisioned some nodes with pods that don't do anything. They just keep some nodes up with a priority class low enough that they will be evicted immediately when other nodes need to be deployed there.
One note here, we expose these settings in the Helm charts to the teams that owns the various services. So if you look at what they can actually change in the generated YAML, it's very few things, and this is one of them. So we kind of decentralize managing resources to the teams that operate the services, and we have this kind of continuous accountability conversations where, what did you do? So right now, after a few years of doing that, every team is pretty educated on what they need, and they are reliable to configure their services properly.
And each service has a dashboard in Grafana with the resources, so they kind of know what resources need to allocate to that.
There's a question, how do we handle scaling batch jobs for our workers and stuff?
We use the same warmer technique. We have HPAs set up for workers also, or just normal auto scaling based on memory and CPU.
So not a big difference compared to the other workloads.
Yeah.
and I'll quickly wrap up. We do all these things, but there's always something that catches us by surprise. So every month when we receive the invoice from our dear Google Cloud reseller, we, it's again the same amount like last month. There was no unexpected optimization. And we do the breakdown of the previous month by project, by service. This is a actual cost breakdown of our last year, and you can see it's, I don't know, 100 to 150 monthly, and it's BigQuery and compute, the big buckets. And we tend to find a lot of anomalies, like maybe some teams work hard to optimize their code or their usage, but some other teams introduce extra workloads. So just using the total invoice as a metric is not very useful. So we have this discipline to look, to break down the cost every month and see anomalies. When we see potential repeated offenders, we introduce budget alerts. This is mostly happening with BigQuery when you have maybe some dashboards that refresh too quickly or stuff like that. And the optimization we do and the monitoring we do is continuous. So there's no point where we say, okay, now everything is pretty well optimized. So, but it does get harder to find useful action items. Right now, if I'm to think, okay, what are plans for cost optimization? Not much. We don't have any great ideas. Most good ideas we implemented. So it's kind of hard to squeeze some performance if you do this continuously, but we'll still try. Maybe we move more of the batch work to preemptible instances if we can break down the workers in discrete stateless work, or it becomes more complex and more costly to cut costs as the time passes. And we also have a lot of people that look at these billing reports, the finance team, our engineering team, the platform engineers. So there's always somebody that spots something. And we learn most from our screw-ups. And let Mihai tell you a story.
It's not always, some rocket science. Sometimes we just do stupid things like forgetting about the policy in the storage class. So in our dev cluster, we use persistent volumes for all the Redis instances, and there are consistent number of them deployed in all the namespaces in dev. So we left the priority in the storage class on retain. So each time someone deleted the Redis and spin up a new one, that volume would be left behind. And it was just accumulating on volumes on SSDs in Google that we were paying for nothing. So sometimes it's just some stupid things. No, we don't have a question slide, so.
So I have so what represents the part of the bars?
It's BigQuery and compute breakdown by Google Cloud Service. BigQuery data stuff.
To put this into perspective, how many app users do you have? Or website users? Website also served using this platform, or it's just API backend we were discussing about some rough figures? I don't know.
Yeah. I didn't check the statistics in a while. We have three apps, iOS, Android, and the web app that use the same API gateway. So the workload that we see here is mostly the public-facing API gateway. And in terms of numbers, we have, I don't know, tens of millions of users and millions of paying customers, something like that.
Excellent, yeah.
We just started selling on Zalando, so perhaps we'll cover Romania soon, but not on our infrastructure.
What are some best practices when making tests, load tests?
Well, we had a cloud native event last year that was focused on that, and the presentation is recorded, so I'll share the link after. But I think it's first of all understanding that you have three types of tests. You have stress, performance, and spike testing. And for stress testing, load, stress, and spike testing. And for load testing, you kind of want to see the app performing in normal load conditions, and that should happen regularly. And this should inform anomalies in the systems that we operate. Either an application became heavier between some deploys and so on. And this is the bit that we need to do continuously to make sure we don't have unplanned increases in decreases of performance. And then for spike testing, we need to make sure our systems react appropriately under unexpected spikes of traffic, like a TV ad or some other instantaneous event. And this is mostly testing our ability to scale immediately. And the stress testing is trying to identify bottleneck choke points in scenarios that are way beyond the realistic expectations, like 10x the most expected traffic. And that's where we find, let's say, weak spots of our architecture, where maybe we have a single point of failure that is not able to scale anymore, stuff like that. So I think from a principal point of view, we have to think about the purpose of the tests, and there are these types of tests. And then I think kind of decentralizing the use cases is important, because as you have many engineering teams, it's going to be difficult for one person or team to maintain all the scenarios. So having contributors from the rest of the company probably is important. And reducing the overhead to operate the performance test system is important, because otherwise you just don't run it. So it should be kind of easy, cheap, affordable, and low overhead to run the tests. So automate as much as possible. I don't know. Cătălin, did I miss anything? No? Okay.
Wasn't expecting that.
Yeah. Yes?
How do you prevent overspending on stateful services like MySQL databases?
You go.
Yeah, we don't keep MySQL in Kubernetes.
You can still overpay for it, right? So,
Yeah.
Well, it's not.
Friday and you have to scale it properly.
It's not automatically scalable as we speak. So we have a fixed cost with that, and for Black Friday, yeah, we do special.
There is no magical answer from us today. It's through, I know, wisdom and hard DBA work. But I think one thing that is worth mentioning is disaster recovery is super expensive, and we pay that premium. We have cross-region replicas. We have delayed replicas. Like if a programmer would say, delete some unwanted records, we still have a replica that has them, that is kind of recent, and we don't have to rely on yesterday's backup. So there are things we put in place for disaster recovery, and they're kind of expensive, but that's it.
Do you keep a record of what changes were done and what improvements were recognized after deployment, or before the deployment? Do you keep a tag on what you're expecting to happen and comparing it to the reality?
We just keep the regular records that any team keeps, like Jira tickets and whatnot. There's no structured way to measure performance consequences to various deploys. Not that I know of anyway.
I mean, I think the closest thing we have is annotating each deploy in Grafana on a dashboard with, error rates and something like that. So if we see that the error rates have spiked just after we annotated that it was a deployment in Grafana, we know where to go, which app. We see what happened in that release, and that's kind
I
of.
was more concerned about the performance changes.
Yeah.
Not necessarily the error rates.
We have multiple.
Since you have the annotation, you can choose to display whatever metrics you want, like load time or response time.
I just chose that example, but we have also response time.
One thing I would rather maybe have more questions after, because we still have one talk left.
CI/CD, not a good idea. You will get a lot of drops during the deployment.
Thank you.
Everybody will get.
Nu mai facem nicio pauză, că a venit pizza. We power through the last talk and then we eat. Aș vrea să-ți dau și niște lucruri, da? Ai link-ul de deployment? Nu.
E posibil să nu mai... Băia e caldă? Ține un pic apăsat și acum... No, tot pe ăla din mijloc, dacă e cercul albastru, e rece. Ia.
Și
Să te ajut? La rețea? La Wi-Fi?
Trebuie să mă conectez la rețea? Nu pot să mă conectez. O să mă omoare la de la security.
Vrei să-mi dai... Nu știu.
E ok. Și acum ce am făcut? Trebuie să intru pe... Nu, dă-mi aici.
Companion mode. Use companion mode. Și acum să-i okay. Și dai share Windows sau full screen e o chestie de la browser, nu
Pe ce schimb să ai?
Ai numit și terminal sau chestia asta?
Nu, e doar prezent.
O să începem! Vă rog să luați un loc și să vă puneți telefoanele pe modul silențios.
Yep. Can you hear me? I never used this kind of technology. So I am Mihai Bogdan. I'm a community leader for AWS Group. I'm a freshly leader, and I'm also a team lead for Atelier on the company where I work. And of course, I'm an infidel because I use AWS. And I pay the price. So you will see in these two big incidents, it's a very good transition from the previous slide. I know it's AWS related, but there are lessons that you can learn from this, and I feel that you'll find them quite interesting. Just to give you some background, we are cloud agnostic. We are AWS partners. We started with our COPS clusters. We have workloads, the number of thousands of pods running continually on production. And we developed with AWS the EKS solution they offer. And also now we are transitioning towards serverless. You will see the stages of our mistakes. And yeah, we are eager to learn about AI and make a mistake there as well. So we have only two case studies. These are the most expensive ones. But as you can imagine, we had more. First of which is honeycomb integration incident. I'm not sure if you guys are familiar with honeycomb. Anyone? Okay, it's an observability solution we used for our platform. We are not using it anymore, of course. We also used it for the things that was not designed to be used. Keep that in mind. We used for the load balancer logs, the application load balancer logs. And of course, that the incident was caused by their agentless integration, which was like a Kubernetes operator that runs inside Kubernetes, and it monitors our application load balancer, ingresses, and all that to provide us visibility into the networking of the cluster. I presented a timeline with the bullseye icon because we needed 3 hits to get the jackpot, of course. So first of all, the incident began with an update attempt via CloudFormation. To give you more background, this integration was developed in a CloudFormation stack. We use Terraform, so we don't really like CloudFormation. And it began with the call from the security guys. Hey guys, you have a Lambda function that is running obsolete node versions. You need to update it. So that was the first bullseye. The second one, we were also in a transition to migrate the paying account, the central account. That's an important second point there. And of course, it had to start on Friday because that's the best time to do migrations and tests. The failure details are presented there. The CloudFormation stack failed, of course. Lambda version didn't update, so we went home happily. It failed, it's not our fault, we start Monday. But of course, the environment variables were reset, and we didn't look there, so we paid the price. Big time. So when we came Monday to the office, we saw that the forecast bill was $200,000. And that was because during the weekend, we incurred $28,000 for the CloudWatch ingest. So basically, basically that Lambda function continuously ran because it was badly designed for that custom integration that I mentioned. And we had no billing alarms because of the management account transition, of course. And yeah, it was the weekend, so Monday morning, I was there, first responder, looked at the logs, and I crashed, basically. Yeah. And we had our CTO from USA visiting us in that day. So it was like we were at the computer, very sweaty, and he was like, everything okay? No. Okay. I come back in 1 hour and you will tell me. Yeah, sure. Identification. So high-cast discover, action taken. Of course, we disabled the Lambda function. It was very obvious because we always keep a log of what we are doing Friday. And we knew that that was one of the things. So that was the first one we checked. The part that we are not really pleased with was the communication with AWS. As you can see down there, it took 4 months to complete. We had to provide a full, of course, you need credits because nobody will pay for that amount of money. So we wanted to provide a full issue report. We worked on that. We had to provide proof that we removed the outdated solution. And of course, they require some detail with evidence of the preventive measures implemented. So yeah, that was the process. It was back and forth. We didn't have the higher tier support, which was the enterprise support at that time. So we had to go back and forth with them. This is why it took so much time. What preventive measures we took, basically? So we added budget alarms because the transition completed on that day. We enabled them throughout all accounts and used SMS notification for the budget alarms. Keep that in mind for the next bullseye. We deployed our AWS Cost API solution. We have our own because the one that AWS offers is quite buggy. They worked on it, so it's more stable. This is why I mentioned it here, but the link is not that great. So they have a cloud intelligence dashboard solution that you deploy with CloudFormation, and that will show you an overview over the history of the bills, what's good, what's not, what's the thing. We also added the CloudWatch alarms for put log events and incoming bytes. We didn't have those. Imagine that. And we decommissioned obsolete solution, which was the honeycomb solution entirely because we were already looking for another solution. So we were already wanted to drop honeycomb. After all this negotiation part, we secured 50% of the credits only because the other half was you need to go to honeycomb. But of course, honeycomb was not there anymore, so we paid that price. And of course, we enhanced our monitoring, improved alerting infrastructure to prevent further incidents. This is what we thought. We were very, no other incidents, boss, this is all. You pay this, is fine. Yeah, sure. And this was in 2021. Yeah. 2 years later, yeah. We migrated to serverless. So our plan is to transition from Kubernetes to serverless. And now we transition to AI. So next year, I will have another slide here. So serverless service development incident. Everything is good when it's serverless, right? Everything is cheap. You don't see the servers. You just know it's there. You just run your code, and that's it. Serverless is wonderful. Yeah. So we had our several Lambda functions under development, and now we have a lot of bullseye, but at least, yeah, we had one that reduced them to free. So incident began with the deployment of our new serverless service, which was still under development, not properly reviewed. This is important, and not end-to-end tested. This is another important thing to mention. And also it's a good transition to what Alexandru told you about the downscaling of the environment. That was one of our problems. Of course, we didn't, the developers didn't create the proper metrics and alerting, nor our DevOps team was informed of the new service. Of course, it started Friday because, again, we have a scheduler to downscale all of our dev environments. We have like 40 of them. During the working hours between 7 and 8 in the morning, and then during the full days of weekend, they are gone. So this is why it manifested itself Friday, because that developer considered to deploy it on Friday to test some things. He forgot to remove it from there, and then it stayed there. And also the fourth bullseye was, remember that SMS thing? There's a limit. What? You have a question?
Consider switching the end of sprint to Thursday?
Yes, I should do that. We have a rule, never deploy on Friday. This developer was new. It's the best rule. And yeah, imagine that SMS has a default limit, and that is $1. And there's not very well presented by AWS, so you don't know about it. It's just there, a limit. Okay. But we have enterprise support that costs a lot, so it's a lot. Yeah. Code issue I already presented you. The best part is that the concurrency was set to 10,000 lambdas, which means you can run 10,000 lambdas in parallel, because why not? You just want to see. Yeah, so of course, yeah. We were a little bit prepared, okay? Yeah. Financial impact, as you can see there, is not that high because, yeah, we at least learned some things. And we actually got pinged earlier. Of course, and also what saved us was that this particular environment was not running, was not down the entire weekend, was down only after the working hours, because that dev changed the scaling, and that saved half of the bill. So it was more expensive if it wouldn't be that. Of course, it didn't have CloudWatch alarm for each component, and yeah, that unreliable budget SMS notification, which we thought is reliant, but it wasn't. Identification, discovered the issue Monday morning. I say here Monday morning, but it was like Sunday. No, it's Sunday. Sunday, Dominica? Sunday, yeah. Sunday night. It was like 1 a.m. when I was like, I have this email. What's this about? Yeah, so saved us a couple of grand. Active, taken, fixed, and deployed a new version. Of course, this is what I did at 1 a.m. or 2 a.m. And then I immediately called our TAM, and we went through the route of issue report, proof of mitigation, the root cause, details of evidence, and request the credits. As you can see down the bottom, we negotiated. We received a 200% of credit after only 1 month.
You should do this more often.
I just want to mention, so our TAM was not involved in the part of getting more credits, but he was involved in the part where we fixed it in 1 month. We were able to get the 200% credits because of the SMS quota. That was their fault. So they said, okay, it's our fault. You didn't know. So what we did was preventive measures. We drop the more expensive and useless SMS notification. Why I say it's useless? Because in order for our use case to work, that was the cost per month. So it was useless. What we did, we configured the budget alarms to trigger directly our on-call solution tool, rotation tool. We didn't want to do that in first because we consider that it will spam a lot of people and they will drop the alarms like, oh, it's just a budget alarm, I'm not. Because you will see the way it works, budget alarms. You set a threshold in which is safe for you. And if it runs out like $2, it will call you. And it's very, yeah, it's very, I don't know.
Noisy.
Yeah, it's noisy, exactly. Yes.
Do you think that having multiple accounts will help you in this situation? I'm just asking.
Multiple accounts of what?
Like multiple accounts for different services, different teams, different whatever.
We have that, yeah. We have that. We have a bunch of, so the budget alarm needs to be on all the accounts. And you need to set budget alarms for each account. And until now, you couldn't do it with Terraform, so you had to do it manual, but now you can do Terraform.
My assumption is that everybody in Zoom has one account or multiple accounts, but limited to one organization or department and having small slices, but limited the damage, right?
Yeah, we limit the damages.
But I never did it. Right? I don't know.
Yeah. And we also implemented proper monitoring and procedures for new service development lifecycle. And this is important. You need to have procedures in place. You need to have a clear way for the developers to not deploy on Friday on the environment that is not tested. And he needs to be the owner of the solution and the account that he provides. We have this thing, one thing. We have this kind of work where each developer has its own account, each team has its own account, and we have the leader and the architect of that team that is responsible for the cost. And that was the main reason for the procedure. Yes, question.
Question, how much of those procedures were enforced through some toolchain automation and how much through, people interaction?
Yeah, the procedure part on our end is very automated. We have a CI/CD pipeline for it. We have all the procedures in GitHub, and we have a chain of command like I load the procedure, that procedure gets signed by all the other parties, and then we automatically send that over the email to the developer to acknowledge it. So it's pretty automated. So I have the lesson learned part. Monitoring and alerting, important of comprehensive monitoring and alerting system from stage 0. What I mean stage 0, we had a bunch of meetings with the developers to tell them, hey guys, you need to not only develop your solution and the tests for your code, but also monitoring and alerting, because we as a DevOps team here at Atelier, we offer platform as a service, so they create their own infrastructure. We just maintain the basic, the baseline parts. Cost analysis, that part is another valuable asset. You need to have detailed cost analysis and also historical comparison. I don't advise you to use the forecast and also the anomaly detection part from AWS. That one is very buggy and it will call you every day, every single time. Negotiation strategies. As you saw, you need to be very transparent with AWS. There's no reason for you to hide. I mean, it's a mistake that you did. They need to understand that you acknowledge that it's your fault for some part of the things, where it's your fault. And there's no reason for you to hide things because they will find out. And yeah, it's just better to be transparent and give them all the details that they require. And having a TAM will definitely help you. Redundant alerts, that's another part. Ensuring redundancy in critical alerting mechanism. Exactly. So we only counted on SMS and email. We now have SMS, not with that amount of credits. And we have the on-call solution and the email, and we are working on an AI bot now. So that will go very great, yeah. And responsibility, this is the last one, but it's quite as important as the first one. You need to have a clear responsibility for cost management and monitoring. Each team should have designated members who are accountable for tracking and optimizing cost. And this is what I'm telling to all the devs. When you develop something, please consider the cost as well, not only go cowboy and things like that. So yeah, these are the lessons learned. So I have a Q&A session. Yeah.
How would you be able to tell if the increase in costs is due to new deployment code or seasonal event?
Yeah.
Because most likely before, let's say, Black Friday, you have new code. You work until the last moment and you have a deployment. And
yeah.
that might go any direction.
Exactly. And I'm very glad you asked that. We really had that case. So we had that case. We are in a current optimization stage where we pick the right compute for our workloads. And we entered pretty deep into them and we cut the cost quite deeply. But what we didn't saw was that our NAT gateway cost started to rise. But we didn't saw it because we reduced the cost so much that the NAT cost didn't show up. So we were like, well, we were so happy because we looked at the metric for the EC2 instance cost, the compute cost, let's say that. But we weren't looking at the networking cost. And one of our clients said, hey guys, when are you going to bring us those improvements for cost? Where are we gonna see it? They are there, they are already applied. No, they aren't. And they send us the graph. And we saw that we basically reduced quite a bit from the overall cost because the cost from compute was to NAT gateway. And we analyzed it. We saw that we increased the SQS traffic, and having a NAT and not having an endpoint for the SQS was going through the internet. So yeah, we added that endpoint and we saw. So it happened to us. And yeah, we were lucky, but most likely you need to look at the build. And this is that part with, of course you are. Of course. Of cost analysis. You need to have someone responsible to look at the cost analysis, to analyze those dashboards we are doing daily. And also you will get pinged if you overcome your budget. Once you put a budget on all of your accounts, you will get pinged if something is wrong and you will check, most likely. Yeah.
Nice.
Yep.
We have on our policy to not deploy or do changes in production on Friday.
So for production is.
Well, I want to give you some context because I think that having this kind of rules, not changing stuff in production on Friday, is not that issue, right? Not issue of having changes production on Friday, but a deeper level issue, right? Like not testing correctly, not doing load tests, stress tests, whatever, performance testing, right?
Exactly. Yeah.
So yeah, not Friday, but focus on other things.
Exactly. No, we are deploying now frequently. We are deploying over the weekend as well. So we are not at that stage. This is 2022 and a half. Yeah. Other questions? Yeah.
So this question is regarding responsibility.
Yeah.
Who receives the SMS text or the alarms? And how do you decide who is going to take action in case of an emergency? You gave that example when you woke up at 1 a.m. and you took action.
Yeah.
How is this decided? How come you had to do this?
Exactly. I was the on-call person at that time, and I had another incident. But usually how we are doing, we have the on-call rotation for the working hours and for the weekend. And they are the first responders. They need to check even for the budget alarms, and if they know how to fix it, they will fix it. If not, they will ping another, escalate. Yeah.
So basically the people, the members that are accountable for tracking and optimizing costs are also the ones that are called when there is an event, and they know or they're different people than the one.
No, they are different people.
Oh, they're different people.
So we have the on-call team that does that. And then based on the analysis that we are doing to evaluate what happened and to generate the report and all that, we will speak with the accountable people from that team and find out what slipped, what they didn't see, and what went wrong, basically.
To rephrase that, did it ever happen that the person that introduced the problem woke up at night?
Yes, it did. It did. It actually did. No, just once. Yeah. Yeah, it's satisfying. That's it?
No, maybe let's eat.
Let's eat, yes. If you have no other questions, then that's it. Thank you.
We will continue the Q&A session while being present. Inebriated. Bye-bye.